So let me start with a new model here, and then drag a sine wave from the standard sources library, an integrator from the continuous library, and a scope from the standard sinks library. And I can connect up from the output of the sine wave to the input of the integrator, and click on the integrator block, hold down the control key and click on the scope block to automatically create a connection between the output of the integrator to the input of the scope block. So what I'm doing by connecting the output of a block to an input of another block is creating a flow of a time varying signal from a source to a sink. By connecting the outputs of one block to the input of another block, we form a mathematical relationship between the connected blocks. These lines that connect the blocks are what we call signals, and they are time varying quantities. While time is not explicitly shown in the Simulink model, Simulink integrates time into its models, meaning that everything in the model is exercised by Simulink's timing engine. Each block essentially has a set of equations that can be solved as a function of time. This distinguishes Simulink from C, for example, in that it is a high-level language providing a canvas to simulate the dynamics of a time-varying system without having to write mathematical solvers for the time-varying part. The blocks thus provide a set of equations as opposed to an operation that might be provided by a high-level programming language like C. So let me now save this model at this point. Now let's look at this model in a little more detail. Connected up some blocks, but we don't really understand what the integrator is doing, and we're not sure what the parameters are. So let's double click on the integrator block. Double clicking on any block in Simulink brings up the parameters dialog box for that block. The parameters for every block are different, and if you look through this dialog box here, we can see that the integrator has an initial condition, has options to limit the output of the integrator, has an option to turn on saturation port or to turn on the state port. But let's see what all of this means for the integrator. Clicking on the help will bring up the help browser with more information about the parameters and this block. So here you can see the equation that the integrator block models, how you might define initial conditions, how you might limit the integral, how you might reset the state of the integral, and how you might use the integrator block within your own algorithm using standard examples. Key point here is that all Simulink blocks in the standard libraries have detailed help. So you know what you're doing, and you know how changing the parameters will affect the simulation for each block. Let's close out the help and come back to this. So we know that I'm integrating the sine wave that has a value of 0 at time 0, and you know that integral of sine 0 is minus cosine 0, which is minus 1. So instead of starting with an initial condition of 0, I'm going to set the initial condition of the integrator to minus 1 and say OK. Save the model, and I click this button to simulate it. Double click the scope to bring up the output of the scope. So you can see that the integral of the sine wave is a cosine wave, as we expect. You might say this is a very simple task, and what advantage does Simulink provide as opposed to doing this in C? Well, even for the simple example, Simulink has provided you a quick way to develop your system model without writing your own solver. Even writing a simple Euler solver would take a significant amount of time, and what Simulink has allowed you to do in this case is model your algorithm or the math of your system without having to focus your energies on writing a solver.